Coral reef populations have been devastated recently. Since 1970, the coral population in the Florida Keys has decreased by greater than 70%. These are near catastrophic numbers. As a result, scientists have been working tirelessly to stop the destruction and formulate a plan on how to rebuild these essential habitats. All corals tested were harvested from Wonderland Reef and returned after experimentation with a 0% mortality rate. No corals were harmed in the creation of this film. Scientific knowledge is based on observation and inference. It is important to recognize that these are very different things. Not only does science require creativity in its methods and processes, but also in its questions and explanation. This idea was never more relevant to me than after my summer internship at the Smithsonian Marine Station in Fort Pierce, Florida. My name is Eric Weil, and this summer I worked with Dr. Jennifer Sneed to help her with her research trying to isolate a chemical compound from a bacterium that would encourage coral larvae to undergo metamorphosis and settle. Dr. Sneed and I spent 7 days at Mote Marine Lab in Summerlin Key, Florida, collecting larvae and testing the effects that different compounds had on the larvae. We observed that the compound tetrabromopiryl, when added to filtered seawater, encouraged the larvae to settle. From this observation, we can now make the inference that this compound causes the larvae to settle. Believe it or not, but this is how scientific research starts. This is also where my question started. Now that we determined the compound was responsible for settlement, I was curious to know if the concentration of the compound produced from the bacterium was different in high nutrient areas versus low nutrient areas. We set up an experiment to test this question using different concentrations of nutrient-rich marine broth and filtered seawater to observe if there is a difference in the concentrations produced. We saw that more bacteria were produced from the higher nutrient concentrations, but an equal amount of compound was present. Aha! Another observation. And from that we can make an inference that the nutrient concentration does not affect the amount of compound produced. Observation and inferences drive scientific discovery. By observing the outside world, we ask questions and then find explanations to these questions. Who knows what questions can arise from your random observations? So go outside and stay observant, because today's observations could be tomorrow's discoveries. For more information on my research or the research of other ocean scientists, go to coastseaflorida.org.